Hi everyone, in this video we are going to study about geospatial indexing. In the previous videos we have covered about B trees and B plus indexing, hash indexing and inverted indexing. Now let's see what is geospatial indexing as well. Before studying the geospatial indexing, we should understand what's the actual problem and what it's going to solve. So let's say that this is the coordinates. Okay, this is a simple plane and this plane, let's say it's Delhi. In Delhi, and there are some restaurants. Okay, this is our Pizza Hut, this is my Domino's, this is the Burger King, and there are some other restaurants as well. And now you are standing at this point. Let's say you are standing at this location. And now what you want to figure out the nearest restaurant. Okay, this can be one query. You want to figure out the nearest restaurant. Secondly, you also want all the restaurants that are under 1 kilometer, something like this. Secondly, you also want to figure out that all the Uber drivers that are near you, and restaurants are static, but Uber drivers are continuously changing their location and their coordinates are changing. So this is a dynamic problem. Okay, so I will just wrote it down here as well, the Uber driver thing. So these are the three problems that this geospatial indexing is going to solve. So let's suppose that in our database we have our latitude and longitude stored of everything. Let's say we have a table. In the table there is a Pizza Hut and we have the latitude and longitude stored. Again Domino's latitude and longitude stored. And now what we are going to do, we are going to provide our latitude and longitude. And the problem is that we need to know all the coordinates. We need to figure out all the restaurants that are going to lie under 1 kilometer. So this is a problem that we are going to see first of all. So let's say that you are standing at this location according to my image. This is the point in which you are standing. My latitude and longitude can be 100 and I think 200 is the perfect answer for it. Let me just, for this coordinate is going to be 100 and 200. In our longitudes, you have to go on the left hand side to 80 point. In our longitude in the right hand side, you have to go to this 120 point. Same, in our latitudes, you have to go to 100 and 300. So when we are going to run a search query on this particular thing, so what is going to happen? The first of all, the end query for the latitudes is going to give me this data, 100 and 300, this data. Okay, the complete list of all the rows that are lie under 100 and 300 coordinates. After that, you are going to run the query on the longitude 80 and 120 that are lying here. Okay, and after that, you are going to merge this thing. This is how our select query is working. And you will be able to figure out all the places that are going to be present in this particular space that are 1 kilometer away from the user. And you can just return all the restaurants. This is how our query is going to work. Of course, you can improvise the speed of searching with the help of the B trees and B plus trees. But this particular section, this merging will also take a lot of time. So we need some fast indexing over this rows, over this table. How we can do it? We are going to do it with the help of the geospatial indexing, because B trees and B plus tree are going to fail at this point whenever we have a 2D data, because there is a lot of merging going to happen and merging will take a lot of time and it will eventually slow down the speed of the query. Now let's see. There are the three types of geospatial indexing that we are going to cover. The first one is going to be geohashing, second one is quadtree, and third one is the R-tree. R-trees are the improvisation on the quadtrees that we are going to see. So let's start with, first of all, geohashing. In the geohashing, what we are going to do, first of all, let's say this is my whole plane. Let's say this is my whole plane again, and we are going to divide this place into 4 halves. Okay, the first coordinate is going to be 0, second is 1, third one is 2, and the fourth one is 4. This is how I'm going to divide it and I just keep it here. Let's say the same thing and just divide the block 0, 1, 2 and 3. I think this is clear to you. After that, I'm going to divide this particular 0 part again into 2 parts. This 0 is going to divide it into 0, 1, 0, 0, 0, 0, 1, 0, 2 and 0, 3. Same, this 1 is also going to be divided into 1, 0, 1, 1, 1, 2, 1, 3. This is also going to be divided. This is also going to be divided. So we make the small square boxes. First of all, we divide the whole box. After that, what we did, we divide that square box into more small pieces. Again, what we can do, we can just divide this piece as well. So again, its name going to be 0, 0, 0, 0, 0, 1, 0, 0, 2, 0, 0, 3. If we divide this particular box, okay, we can divide it as well. So suppose if the user is standing on the 0, 3 location. Now what we want to return the data. We are just going to say that give the data of 0, 1, 0, 2, 2, 1, 2, 0, 1, 2, 1, 0 and 1, 3, 0. This is the data that we have to return. we are just making a very small box, but it's going to be containing like lot of data. So we are just going to return all the places that are near this box. This is known as geohashing. So this geohashing is also going to be implicated over the B trees, but in our 2D plane. This is the important point. This geohash is also used by Redis. And by default in Redis, in my Redis playlist, I also covered this geohashing point, like how we can use this geohashing in our Redis by default. This particular problem is going to work very well when our data is static, because nothing is going to change. Let's say Domino's coordinates are going to be same every single time. It's going to be changed, like our write operation is going to be very less in this case. Our values are not changing in this situation. Everything is pretty fine and it's work very well with static data. Geohashing is very good with static data. Now let's understand when the data is going to be dynamic. When we have a problem, something related to Uber drivers that are continuously changing the location. Let's say in a case of Uber, what is going to happen? In Bangalore, the traffic is going to be more. We have more Uber drivers in very less space. But let's say in Aligarh or in any small city, what is going to happen? The Uber drivers are going to be very less. So we need some spatial type of hashing or indexing technique to solve this problem of Ubers. Let's understand it. To solve the problem of density and continuously change of place, we are going to use Quadtrees. Quadtrees is nothing but again the same logic. First of all, we are going to divide our map, our square box into 4 coordinates. That is going to be 0, 1, 2 and 3. And we are going to maintain one number k. Let's say k is equals to 3. This k is saying that whenever the density is going to be more than the k, we are going to divide that particular square box. This is a simple logic. Let's say what is happening here. There are 3 coordinates. There is no problem. But let's say their number is going to be 4. In that case, we are going to divide it. Here, there is a number is 2. There is no issue. But in this situation, you can understand it. Let's say whenever we have more than 3 points, then what is happening in this case? The first, this particular section is divided. This has 0 element, this has 0 element, this has particularly 1 element, this is having 3 elements. Now this area is also divided because it is having 3 elements, 2 and 1 element. Now let's say what is going to happen. In this case, let's say there is one more element is going to come. This element is going to join this space. So what is going to happen in this scenario? We are going to divide this space, something like. Okay, so this is a recursive tree that we are forming. In our geohashing also we are following the recursive tree, and here also we are forming our recursive tree. So this how is tree going to be look? It's an implication, like it's a modification on a B tree in our 2D spaces. Again, I just want to remember, I want you to remember this point again one more time. So this is my root node that is having the 4 children, this 4 children. Children 1, children 2, children 3 and children 4. It will be something like children 1, 0, children 1, children 2 and children 3. So it will have 3 elements, 2 elements. This is our children 3 and children 4. Now this children is going to have multiple like 4 children. 1, 2, 3, 4 because it is divided into 4 sections. 3 children, 0 children, 0 children, 0 children, something like this. After that, this element is again divided into 4 sections. Now let's say it has more density. Now it is again going to be divided. This is how our B tree is going to grow, and this is known as Quadtrees. What we are using, we are just maintaining a k element, and whenever the density is going to be high, we are just going to increase our tree in that direction. So let's say if this square box is denoting the India, so this area is particularly denoting the Bangalore because the density is going to be high. So it means that our B tree at this location is going to be, the height of the B tree is going to be high at the Bangalore location. But in general, the B tree is going to be small for all the other locations. This is how our Quadtrees are going to work. Now let's understand the R trees as well. So R trees we generally use in production. It's a modification over Quadtrees. Postgres use R trees internally to solve the problem of 2D planes. In it, the basic concept is going to be same. It's not necessary that we are going to make the shape of a square. We can also make the shape of a rectangle. And the second point is we can also overlap in this case. Previously, we are not overlapping. Okay. In the R trees, we can overlap one square over the other for better answers. This is all about R trees, and we use R trees in production with Postgres. So this is all about the R trees, and I think we are done with this geospatial indexing as well. So thank you for watching me, and let's meet in our next video. Bye bye.